AWS Step Functions is a fully managed service that lets you build resilient workflows by connecting AWS services with just a few clicks. Instead of writing complex code, you can visually design and automate processes, making your application more reliable and scalable. In this video, I'm going to introduce you to the AWS Step Functions service. And to make learning fun, I've built a simple but addictive little game you can launch on AWS using Step Functions, Lambda, and API Gateway, so you'll get your hands-on experience while having a blast. Let's get started. So when you build an application, that application is going to have several steps or processes to follow from start to finish to offer the services intended to offer. So here's an example of the Richer Roast coffee shop application, where you basically go in and purchase beverages and snacks and all that wonderful, delicious cinnamon Danish from the Richer Roast coffee shop. Now, the way how it would work is, you'd search for the item. So all of the different beverages, the snacks, the donuts, the cakes, etc. You'd place the order. Once you place the order, that would go into a checkout. So then you'll click on the checkout button and see what you have ordered. Then you need to go through the payment process. So you're going to put in your credit card or debit card details and pray to God that your payment gets accepted. And then obviously, when your payment does get accepted, the order will be confirmed. Your cinnamon Danish and your latte is going to be sent out to you, and the customer database table is going to be updated. So it maintains a history of all of the cinnamon Danishes you've been ordering over the last year. Now, this is one workflow. Okay, this is one set of process that has several different steps to follow. But this workflow could take another turn. So for instance, when you put in your credit card details, it might get failed. Okay, so the payment process might fail, maybe because you've maxed out your credit cards, because like me, you just had too many cinnamon Danishes over the past few weeks. Okay, at this point, if the payment fails, you want to do something about it. So you may offer another function or another process to handle that particular outcome. And in this case, it might be, okay, offer cash on delivery, so that, I'm going to deliver the cinnamon Danishes to you, and you're going to pay cash, and hopefully you have some cash. And I've spoken enough about cinnamon Danishes, but you get the idea, right? So anyway, the point is your application will have a workflow. Now, you could use Lambda functions to essentially daisy chain this entire process. That is technically possible, but it's a bad idea. If you try to daisy chain Lambda functions, one Lambda function calls another directly, passing data along, you run into several problems. For one thing, you need to understand that you're now building something that's tightly coupled. Each Lambda function has to know about the next one, making the architecture harder to change and update later. Also, you need to take into account and remember that Lambda has this 15-minute timeout period. Now, in the context of this particular architecture, that may not be such an issue, because each individual Lambda function is only going to take a few seconds, if that, to complete. Nevertheless, that's something to bear in mind. And then, of course, Lambdas are designed to be stateless. So you'd need to manually store progress somewhere, like a DynamoDB database table, to know what is the next step. Not to mention the fact that there is going to be potentially debugging difficulty. Tracking where the execution failed becomes tricky, because everything is hidden inside function-to-function calls. And so really what we need is some service that can help us orchestrate this workflow of Lambda functions, because ultimately each Lambda function is designed to perform one specific task. And so that's where step functions come into play. So they help you build distributed applications, automate processes, orchestrate microservices, and create data and machine learning pipelines. So step functions allow you to build what are called state machines. These are essentially workflows that help you to design event-driven architectures and event-driven steps from start to finish, so that your application can complete the purpose that it was designed for. Each step in a workflow is called a state. You use the Amazon States Language, ASL, which is a JSON-based structured language used to define your state machine, which is essentially a collection of states that can do work. So these are called task states, and then determine which state to transition to next, which are called choice states, stop an execution with an error, failed states, and so on. And so let's take a look at a diagram of our Richer Roast application that we were speaking about moments ago. So here's our input. The customer goes in and places an order. That order needs to be validated. We could use a Lambda function for that. So once the order has been placed, once the customer hits the submit button, it can call a Lambda function to validate the order. Once the order has been validated, we can then move on to the payment stage, which could be another Lambda function that steps functions can call. And this would be a choice state. The customer is presented with the page in order to put in their credit or debit card details. They do so, and then they'll hit submit. Here, depending on the outcome of that payment result, whether it's a success or a failure, we're going to make a choice. So if it's a success, we're going to go ahead and process the order and obviously call a particular task. In this case, this task state is just a function that is going to now process the order. Or if it failed, then obviously we'll be calling the fail payment Lambda function. These individual variables help us to determine what choice to make based on the outcome of that state. So if it's a success, go to the process order function. If it's a failure, go to the fail payment function, that kind of thing. And each of these blocks basically represent their individual states, the state that we're in at this point in time. And as a result of that, what should step functions do next? So step functions is going to call all of these different Lambda function based on the event, based on the flow, based on the outcomes of those flow states, and so on and so forth. So just to reiterate, you've got task states, which are units of work that another AWS service will perform, Lambda functions, ECS clusters, EMR, and more. And then you've got flow states that actually control the flow of execution of the steps involved in that step function for your state machine. Now, there are different types of flow states you can have, succeed and failed states. You can also introduce a wait state if you need to wait for the customer to do something, or if you need to wait for a certain process to complete. The choice state, which I've just demonstrated over here how it would work, based on variables, based on outcomes of that state, you'll make a decision as to which function to call next. You can also have parallel states. So in this case, where we have successfully processed the order, obviously we're going to dispatch the order to the customer, but we could also parallelly update a customer database, send out an email and say thank you for your order, that kind of thing. You also have something called map states that allow you to ingest a list which can then be acted upon, so that for every item in that list, you run a specific Lambda function. One more thing. You can also introduce something called an approval step with human intervention. So your workflow might require a human to actually intervene and approve a particular state. Okay, maybe you need to check something, an order, or maybe you need to validate a particular person's credentials. Often, if you have signed up to any of those share trading websites, for instance, it might take a day for your sign up to get approved, and that kind of thing. Now, there are two different types of steps functions workflow types. You've got your standard workflow, which are designed for long running workloads, and these can last up to a year, which means that, pretty much you can handle any type of use case. You can maintain a history of executions for the last 90 days. So it's an excellent audit trail, and it offers what's known as exactly once model. So you don't have any duplicate processing of any of the steps. Or you can have an express workflow, which are actually designed for high volume event processing workloads like IoT data ingestion, streaming data processing and transformation, that kind of thing. Express workflows have a maximum duration of only 5 minutes. And they offer at least once model. So there could be some duplicates and you need to take into account for that. Okay, that's enough of the theory. We've covered a lot of ground and it's time to actually demonstrate how this all works. And I want you guys to be able to actually play with step functions and see how it works. So I've created a very small, simple, but effective game for you to deploy onto the AWS platform using step functions, Lambdas, API gateway, and much more. So let's do that next. Okay, let's talk about the game. This is a simple but effective coffee quiz game. It's going to test your knowledge on coffee beans and the best roast method per bean. And essentially, we're going to work out whether you're a coffee expert or if you just prefer to drink tea. Now, it's called the Great Coffee Bean Quest. And so based on your quiz results, you're either going to brew to perfection or your business is going to go bust. You're going to take your barista skills to the cloud in this fun AWS powered adventure. Let's talk about the actual game features. So essentially, you're going to choose your coffee beans and the appropriate roast method for the bean. AWS Step Functions is where all the magic is going to happen. You're going to watch as the cloud decides if your brew is a masterpiece or a total disaster. It's going to be interactive and fast-paced, and so every choice takes you closer to your coffee glory or caffeine catastrophe. And it's going to be a fun learning twist, so you'll see how AWS Lambda functions and step functions work in a real playful scenario. You can play the game anytime, you can share it with your friends, you can mix and match your choices for new outcomes for each round. And the question is, will you brew to perfection or trigger a coffee crisis? So let's go and take a look at the architecture of this game. Okay, so here's the architecture of the game. The game is going to be hosted on an S3 bucket as a static website endpoint. So that's the front end of it, the client facing end of it, where your users are going to be making those executive coffee decisions. So we're going to have our Richer Roast coffee game application that's going to be accessible on client browsers. And we'll have our customers that are going to be interacting with that client browser, answering quiz results and basically seeing what their results are. Now, the back end of it is managed by Amazon Step Functions. Okay, and in Step Functions, we're going to have 3 different Lambda functions that are being orchestrated and managed by Step Functions. You're going to select the bean, okay, and that's where you make a choice on what bean you want to use. You're going to then decide on the roast method that you're going to apply to the bean. And then the final Lambda function is going to make a decision as to whether you got it right or you got it all wrong. And you should just go back to drinking instant coffee. Ugh, yeah, I know, exactly. So let's take a look at how this is going to work. So your user is obviously going to interact with the website. There's a start button on the application that the user is going to click, which is going to invoke an API gateway call. Okay. And all of the interactions are going to happen through API gateway, because behind this API gateway is a Lambda function called the game controller. This game controller is basically the glue between the front end and the back end. It's responsible for getting all of your customers' inputs and putting them in the appropriate format and sending it to Step Functions. Step Functions is doing what it needs to do best and then sending out the results back through Lambda, through API Gateway back to the front end. So the customer is going to click on the Start button, and that's going to initialize the start sync execution for that step function that you will be creating. And using the initial start variable, it's going to trigger your step functions. So step functions is now ready to kick off. So what's going to happen is, with that clicking on the start button, there's a user input that says that the user has started. And so that is feeding into step function. Step function is going to use that variable to trigger the first Lambda function. The first Lambda function is where you select the beans. And so what's going to happen here is that Step Functions is going to trigger that Lambda function. That Lambda function basically has a prompt for you to select a particular bean. And also it marks the next step as the roast prompt. Okay. So that information is fed back through to the end user, and the end user has to select the bean. When the end user selects the bean chosen, as well as the fact that the next step is now the roast prompt, is going to be fed back through to the game controller, which is going to send that information in the correct format back to Step Functions. Step Function is then going to see that the next step is the roast prompt. Step Function is going to trigger the roast prompt Lambda function with the information that's already acquired, which is basically the bean, right? And so Step Function now has triggered this Lambda function. This Lambda function now has the next prompt, which is what is the roast method you're going to be using. And it also sets the next step in the chain as brew coffee. So that Lambda function is going to send that prompt back to the user. The user is going to make a choice on the roast method, and all of that is being sent back to Step Functions. Step Functions will see that the next step is brew coffee. So Step Functions is going to take all of those input values and pass it through to the brew coffee Lambda function. The brew coffee Lambda function is going to look at the bean chosen, the roast method selected, and make a decision as to whether you win or you lose. And that result is going to be sent back to the end user, and the session is going to be done. Okay, so that is going to be set to true. That's where the game ends. And so the customer or the user can again replay the game by simply clicking the start button again. Okay, and that's as simple as it is. Now, we're going to do this step by step. We're going to be basically setting up, obviously, the individual Lambda functions. So when we do that, I'll quickly show you the code. All of the code is in our GitHub repository, the link of which is available to you in the description of this video or in our resources section, depending on which platform you're using to access this video. But essentially, you're going to have all the code that you need to set this up. Okay, so we're going to have the Lambda functions. We're going to have the step functions, ASL JSON script that's going to help you build out the architecture or the workflow. You're going to have the game controller Lambda function, the API gateway. I'm going to walk you through how to set that up. And obviously there is a frontend index.html file along with some JavaScript that is going to be deployed on an S3 bucket, which needs to be configured as a static website hosting service. And before we go any further, I hope by now you've guessed that we're definitely going to also need to configure some IAM roles for this to work, right? Because we've got various services accessing other services. We need to allow certain permissions in place. So we're going to be playing around with some IAM roles as well. Right, let's get on to the first step. Okay, so step one is where we're going to create an IAM role that's going to be used by your Lambda functions. Now this Lambda IAM role needs some basic permissions to access the CloudWatch service, because what Lambda would do is it will send across a lot of execution information to CloudWatch. It also needs access to step functions and to be able to run certain executions on step functions, but we're not going to add those particular policies yet. The reason being is we first need to create our step function so that we can get hold of the ARN, the Amazon resource name of step functions, which is required by that policy. So the IAM role contains two policies, one for the basic Lambda execution and then one for accessing step functions. So let's get into the AWS Management Console and first set up the IAM role. Okay, so this is my AWS Management Console. I am also operating in the North Virginia region. Okay, so in this particular account, you can use obviously any account that you have to set this all up. I'm just using this particular account. Now, what you want to do first is actually go to IAM and we'll create that IAM role first. Okay, so we're going to go to roles. We're going to click create a role. It's an AWS service, and more specifically, it's for the Lambda use case. Click next. And what we need to do here is basically add a policy for basic Lambda execution. So let me just show you that. So it's this one over here, AWS Lambda basic execution role. I'll just show you what it does. So it allows you to put events to CloudWatch and CloudWatch logs and stuff like that. So nothing too fancy, but we need one of those. Okay, and we'll go ahead and click next, and I'll give this a name. So I'm going to call this the ritual roast Lambda IAM role. Okay, just so that we know what it is. And then I'm going to go ahead and click create role. So as I mentioned earlier, this particular role needs one more policy, which is to connect to step functions, but we'll do that in a while. I'll come back to it. Let's move on to step two. Okay, so in step two, we're going to create the Lambda states function. These are the three Lambda functions that are going to be responsible for actually doing all of the hard work, right? They're going to check the bean, they're going to check the roast, and then they're going to decide whether it's going to brew the coffee or not. So let's get back into the AWS Management Console, create these three Lambda functions. Okay, just before we go any further and actually set up our Lambda functions, I wanted to quickly show you the contents of the Richer Roast coffee game zip file that you should have downloaded and unzipped onto your desktop. So these are the various files in there. So you've got the select beans Python file, the roast prompt Python file, and the brew coffee Python file. These are the three Python files that are going to be used by step functions. So let's take a look at them individually. So if we go to select beans, I'll open that up very quickly. So this basically all it's doing, right, is it's getting the user to provide information as to whether they want to select the Arabica, Robusta, or Liberica roast. And then obviously on top of that, the session state is being set. The next step is going to be the roast prompt step. Okay. And then we've got the roast prompt. Now the roast prompt is actually going to take that information that we already have and validate it. Okay, and then proceed on to the next step. The next step is basically where it's creating a map of the three different coffee beans. Okay, so based on which coffee beans you have selected, it's obviously going to create a map for that. And then what it does is it stores that as a session bean choosing the bean map choice, but then it sets the next step for the brew coffee. So then it moves on to the next step. But with that, it also then sends a prompt to the user that now that you've selected your bean, you now need to select the type of roast you want to apply to the bean. Okay, and then the final Lambda function is the brew coffee Lambda function. And this is where, based on the two inputs that we've had, these input values are managed and maintained by your step functions so that these can be filtered down into the relevant Python execution. And this particular brew coffee Python file is then going to make a decision whether you choose Arabica, whether you choose Robusta or Liberica, and then accordingly which roast method you choose, and then give you a result for that. So those are the three Lambda functions. So I'm going to copy this one very quickly, select bean Lambda function, and we're going to go into the AWS Management Console and create our first Lambda function. Okay, so here we are back on my AWS Management Console. Just going to go into Lambda. So we're going to open that up in another tab. I'm going to go in here and make sure you're obviously in the North Virginia region. Click create function. You're going to author from scratch. This one is called select beans. Okay, just let's get the naming convention right. Select beans, and make sure it's the Python 3.13. And you want to make sure you select the execution role we just created moments ago. So that's the Richer Roast Lambda IAM role. Click create function. Okay, and we're going to come out of that. And in the code, you're going to replace the sample code with the select bean Lambda function code. Let's paste that in there. Okay, so there you are. So that's our code there. That's our Lambda handler. And what we need to do next is go ahead and click deploy. So that deploys our first Lambda function. And that's done. Let's move on to the next one. Okay, so back to our Visual Studio Code. Let's go to the next one. So the next one is the roast prompt Lambda function. Remember what we said over here. This one is basically going to prompt the user to choose the roast type, and obviously take into account that the next step is going to be brew coffee, and it maintains a map of the three different beans type that you would have. Okay, so we're going to copy all of that code, go to the Management Console, and I'm going to go back to functions, click create a function, and this one is called roast prompt. Okay, and we're going to go and click Python 3.13, and again we're using the same Lambda execution role. Okay, and we're going to click create function. Right, now we're going to replace the code that is there. So get rid of that and paste my code in. And there we are. Just bring this down a bit. So we are got everything in there. Yep, the Lambda handler. And then go down and click deploy. And that deploys our second Lambda function that will be managed by Step Functions, which is the roast prompt Lambda function. Okay, so next we're going to deploy the brew coffee Lambda function. So back to Visual Studio, let's copy that in. There we are. So brew coffee. So remember what this is doing now is it's taking both of the user inputs. It's taking the bean chosen and the roast selected, and then making a decision as to whether you're a winner or a loser in terms of your knowledge in coffee anyway. So let's copy that and go back to our Management Console. And we're going to go Lambda functions, click create a function, and we'll call this one brew coffee, like that. Make sure it's Python. Get the execution role in there. Create a function. Don't show this again. And then we want to replace that sample code with our code. And we're looking good. That's all good. Okay. Now, what we need to do next is basically deploy this one as well. Okay, so that is our three functions done. Perfect. Let's move on to the next step. Okay, so now we're going to move on to step 3, which is where we're going to create the Step Functions state machine that is going to manage those Lambda functions. So before we do, let me show you the Amazon States Language JSON code that's included in the GitHub repository so that you can see how that is structured. Okay, so here we are. This is the Amazon Step Functions ASL JSON file. And basically what it does is it's got the choice state to select between the 3 different states that we can be in. And this is going to be based on those Lambda functions saying what the next state is. And so obviously, we're going to start with the start, and then we've got the roast prompt state, and then we've got the brew coffee state. Okay, and the start state reflects the select beans session, the roast prompt obviously to select the type of roast, and then the brew coffee is the one that works out whether you win or lose. And each of these are connected to these individual Lambda functions to invoke their relevant Lambda function. So we've got select bean Lambda function, roast prompt Lambda function, and brew coffee Lambda function. What you will notice is that you have to update the ARNs of these individual functions. So we'll do that as well. So quickly copy all of that to your clipboard. So I'm going to click copy. Let's go back to the AWS Management Console, and we're going to go into Step Functions next. I'm going to open that up in another tab, and we'll create a step function state machine. So what you want to do is click on Get Started, and we're going to be creating our own, and we're going to call this one the Ritual Roast Coffee Quiz Step Functions. Okay, so it's can't be more explicit than that. Click the Express machine type. Okay, so this is the Express machine type for high scale workflows in streaming, data processing, and microservices. And click continue. And this is your console where you're going to build out your state machine. Now you could build this out manually, obviously, by dragging and dropping the individual actions that you're going to take against this between the start and end of your flow. And you've got flows, you've got parallel, choice, map, pass, wait, success, fail, all of those options available to you. And obviously, you can build it out that way. I've obviously got the code for you. So just click on code, and let's paste that code in there. Okay, and that's building it out for you there. So there's 2 ways of doing it. Obviously, you can learn the JSON approach and build it out, which is, relatively easy once you get the hang of it. But you could also use the Visual Console to individually drag and drop those individual items and services that you're going to be calling. So what happens here is that entire JSON script translates to this visual workflow. You've got start, it's a root on step, a choice state, based on the session step variable value. So the session step is being derived at by looking at what the Lambda function is stating. Okay, so the initial Lambda function, the select beans one, has a session step at start. We've got roast prompt and we've got brew coffee. And then based on those, the individual Lambda functions are invoked. Right, and so you got select beans. Once you've selected your beans, then you're going to decide on your roast prompt, and then whether or not you are successfully brewing or not. And that ends up going to the end or next state, and then either it's a success or it's a failure. Okay, and that is the entire workflow. So you can see how this works, how using those individual variables, we know which particular step to call. And once we've made our decision, once we've come to the conclusion, obviously it's going to be a success, and we're going to set the session done to a value of true. So that brings it to an end. If we selected some wrong options, then we will end up with a bad step. Okay, so it's fairly simple. Right, we do need to update these individual steps because you can see that there's the red X's next to them because it means that it can't see what Lambda function you're referring to. So just drag this on this side over here. Let's go to select beans first. Now we got a Lambda function, select beans. We need the function ARN for select beans. There it is. Copy that to your clipboard. And all you're doing is you're just replacing that value there. Okay, so click paste. So that clears that one. The next one is the roast prompt one. Back to functions, roast prompt, copy the ARN. And we're going to plug that value in there. Just paste it in correctly, or else this isn't going to work. Okay, so that's cleared as well. Next one is obviously brew coffee. So let's grab that function ARN. And here we're going to go and paste that in there as well. So paste, so that looks good. So if we now look at our workflow, no more X's. We've got our 3 Lambda functions that have been identified, and we're good. Right, so all looking good so far. So we can go ahead and just click create. And what this is going to do, it's going to create the step functions, and it's going to confirm, and it's going to require you to confirm the creation of the necessary roles so that step functions can talk to these different services. This one gets created for you by step functions itself. So it says an execution role will be created with full permissions. Obviously, you can go in and modify that to your specific requirements, and it's going to give it this particular role name. And then we'll go ahead and click confirm. And so that's going to go ahead and set all of that up in motion. Okay, so the state machine has been successfully created. That's all looking good. Let's move on to the next step. Okay, so step 4 is where we're going to create the game controller Lambda function. Remember, this is the Lambda function that gets all of the inputs from the user via the API gateway. So the API gateway invokes this Lambda function, and this Lambda function then talks to the backend Step Functions service. And so it acts as the glue between the front end and the back end. So let's take a look at the Lambda function code for this one first. Okay, and here we are. This is the game controller Lambda function. So this is basically going to connect to the backend states machine. And so we need to provide the states machine ARN. Now this is provided as an environmental variable. So I'll show you how you set that up within Lambda. And then basically what it's going to do is it's going to check whether the HTTP method is equal to options, and then it's going to return a 200 response code. It's going to take in the inputs from the front end, which is the user input and as well as the step that we're currently in. So currently it will be the start step, and that's going to trigger steps function with the start variable so that step functions knows which Lambda function to call. One thing to remember is that the game controller Lambda function doesn't actually store anything in memory. Remember, Lambda itself is stateless. It just forwards the user's choice and the current session to step functions, and the response of that along with the prompt for the next function is passed back to the end user. Okay, but it acts as that middleman managing the communication between the front end and the back end, ensuring that all of the communication is in the right format. Okay, and so that's where the output of the express sync function is in the express response. And so we get the response. That response goes back to obviously the end user. Okay, so let's quickly grab that code and we'll copy that to the clipboard and go back to our management console. Okay, so here we are. We're going to go into functions, click create a new function, and this is going to be called the game controller function. Okay, and that is going to be the Python runtime. And again, we're going to give it the execution role, which is that one over there. Remember, that still needs to be updated with an additional policy. We'll do that shortly. Click create function. Okay, and then we are going to update this code over here and paste our code in. So that part of it is done. Now, the next thing that we need to do is to go into configuration, and we're going to go into environmental variables, and we're going to create an environmental variable. And if we go back to the code very quickly, so we need to create an environmental variable where the key is state_machine_ARN. So we just copy that to my clipboard. Okay, and add environmental variable, paste that in there, and then the value of the state machine. So we've created our step functions. Let's just close all of that. Okay, and there is the ARN of our Richard Rose Coffee Quiz Step Functions. That's the ARN, so copy that, and you're basically pasting that in the value section of that environmental variable, and then click save. Okay, so that is the environmental variable created for our game controller Lambda function, and obviously we have the code which we've just pasted in there. So that's going to pull it out from the environmental variable. That's all looking good. We click deploy. And that is deploying our Lambda function. Right, that's the end of that step. Let's move on to the next. Okay, so step 5 is where we're going to now create that API gateway. So we're going to create an API so that we can call this game controller Lambda function we just created moments ago. So let's jump back into the AWS Management Console. Okay, so in my AWS Management Console, I'm going to go to API Gateway, open that up in another tab. Okay, click Create an API Gateway. You're creating an HTTP API. This is low latency, cost effective, and offers native core support. And your backends can be things like Lambdas and HTTP backends. So we click Build, and we give this a name. I'm going to call this one the Ritual Roast Game API. And so when we invoke this API, what are we calling? We're calling the Lambda function, the game controller Lambda function. So click Lambda, and then from this list, you're going to make sure that you have to select the game controller Lambda function. There it is there. Okay, and make sure you go in the right region, which you will be, and then click next. So this is the route that you're going to connect to. So when you call the API is going to invoke the Lambda function, and it's going to send a method. And the method that we're using is the post method, and specifically it is to the /game path of this particular Lambda function. And so that is going to the Lambda function and calling the /game path. So go ahead and click next. We're going to set this at the default stage. Okay, so now this is where we'll configure stages. We're going to leave it as a default stage. A stage is just basically a representation of the environment that your application has been deployed in. So you've got dev, test, prod, that kind of thing. And it allows you to separate out those environments. So we're going to leave it at the default stage, and then we're going to click next. And then this is the review and create page. And then we'll go ahead and click create. So this will create the API. So the Richer Rose Game API, with a single route for the post method. Okay, so that all is now successfully configured. So there's a couple of things that we need to do here. We need to go down to cause. Okay, so cause stands for cross-origin resource sharing, which is basically a security feature in web browsers that controls whether web pages from one domain can make requests to a server in another domain. So your Lambda functions and the API gateway specifically is exposing the API on a particular domain, the default API gateway domain name. Okay, whereas the static website service will have its S3 website endpoint, a default website endpoint as well. And so generally your browsers will prevent this sort of cross-origin connections, if you will. And enabling cause just ensures that you allow for that to happen. So we're going to click configure cause, and we're going to allow across all origins. So I'm just going to put in a wildcard. And the control headers is content type. So just type in content -type and add. And we're going to allow the following methods: get post options, and leave everything else as it is, and click save. So that configures our cause for the API gateway. That's done. Let's go down to stages, and you will see we've got our default stage, and that is the invoke URL. That invoke URL is the URL that our front end is going to make a call to, and I'll come on to how that works in a minute. But this is basically your API gateway all up and running and ready to go. Right, let's move on to the next step. Okay, here we are, step 6. Now this is the front end of your application. This is a static website hosted on an S3 bucket that contains HTML, CSS, and some JavaScript that's going to run in the client browser to interact with the backend services. So let's take a look at the code first. Okay, and so back to our Richer Roast game set of files that you should have downloaded. There will be a folder in there called Frontend. If you open that up, there are two files, index.html, which is the front-end code for your website. And then there is obviously our wonderful Richer Roast logo. Let's not forget to add that to the actual website, okay? So that we give that branding for our web application. So let's just take a look at the code in Visual Studio. Okay, and so here we are with the actual index.html page. So the code initially is all of the necessary HTML and CSS styling. Okay, then we actually get into the logo. So we've got our logo to display along with all of the title and stuff, as I had mentioned above. And then this part of it is really critical. Okay, so this is the API URL that you're going to connect to. So we're going to call the API that this particular website will be called when you hit that start button. So this needs to be updated. So let me just go back to the management console, and this is our API gateway. So remember the API invoke URL, we're going to select that and just copy that to my clipboard, go back to the code, and you want to update the code so that you've got the /game at the end. So I'm just pasting that section of it. So that's my API invoke URL /game. That's how it needs to look. Otherwise it's not going to work. You're going to have the front end basically showing you the two buttons. Okay, the first set of buttons, which will be to choose from the different beans, and then the second set of buttons, which would be to choose from the roast method that you're going to adopt. And then obviously it's going to send all of those information as user input via API gateway to the controller, which is going to forward it on to the backend steps function that's going to use that information to run through the various steps that are designed in Lambda or as Lambda functions. So essentially that includes the session state as well as the user input. And then the output of those are then passed back obviously to the end user to see what their results were. Okay, so what I want to do is first save this file. So I've just updated the invoke URL, so that's important. So now that we've saved the file, we're going to go into the management console and create our S3 bucket. So here we are back on my AWS management console. I'm going to go into Amazon S3 and open that up in another tab. And we're using S3 as a static website hosting service to host our front end. So click create a bucket. It's general purpose. I'm going to give it a name. So this is the ritual roast game web. We'll just call it web game. Okay. And turn this one off because obviously it's a public facing website. So we need to block all public access and acknowledge the fact that we're doing that. And then leave everything else as it is and click create bucket. Okay, so that's our bucket created. Now what we need to do is we need to add permissions to allow anonymous users, public users on the internet to be able to access the bucket. So you need to go into permissions. We've obviously turned off the block public access setting, but we still need a bucket policy for this to work. I've got a sample policy for you in my resources in the GitHub repository. So let me just show you where that is. There it is, Amazon S3 bucket policy. You're going to need to update the ARN for your bucket. And here we're going to go to properties. This is the ARN of our bucket. Go back to the code and just update that. Okay. And so it's the Richerous web game ARN. And then remember, you need to put a slash and a wildcard. And what this says is that the users can access the contents of this bucket. That's what we want. So copy all of that. Okay. Okay, it allows the rest of the world to access this bucket, and they can only perform the get object action. Okay, so let's just go back to the management console. Here's our bucket. So we'll go down to permissions, and then click policies, edit the policy, and then just paste that in there. Okay, so that is the policy for the Richerous web game / wildcard, so that will allow public access, and then we'll click save changes. Okay, so now we have updated the permissions of this bucket. Let's just go back to the bucket again. We've also turned off block public access. So the next thing to do is to go into properties, go all the way to the bottom, click static website and click edit, and then you want to enable static website hosting. The index document is just index.html, and then we'll go ahead and click save there as well. Good. Next, we go back into the bucket again. Okay, so really what we need to do now is just upload the files from our Explorer or Finder, depending on which OS you're using. So you pretty much are going to upload these two files to your static website hosting bucket, and we're going to click upload, and the upload has succeeded. Okay, great. So that's the upload now done. So we can now close this one and go back to properties, and obviously this is the website endpoint that we'll connect to. Now there's still one more thing missing. Let me just quickly bring up my source code repository where there is the policy document that you still need to update on that IAM roles. Okay, so this is obviously all of the files you've downloaded. There is one here called the IAM policy Lambda role states permission. So we're going to open that up in Visual Studio, and there it is there. Okay, and what we need to do is we need to update the IAM role for the Lambda function, the Lambda role that we created earlier. And you need to permit these actions. So start execution, send task success, send task failure, and start sync execution. And obviously we need to provide the states machine ARN that Lambda is going to be able to call. So I'm going to go back to my console, and we're going to go into step functions, and this is our step functions, and this is the ARN of our step functions. Go back to the code and just update that placeholder where we need to put the ARN of our step functions in the code. And there it is. And then we're going to copy all of that and create a policy, an inline policy for our IAM role. Okay, so we go to IAM role, and this is the IAM role we created. This is the base permission it has. Click add permissions, click create inline policy, and click JSON, and then replace the template with the code that I've provided, making sure that you've updated the ARN of the step functions state machine. Okay, go all the way to the bottom and click next, and you need to obviously give this a name now. So we'll call this one the ritual roast Lambda to step functions policy. Okay, that is pretty self-explanatory now. And then click create policy. So at this stage, we now have that basic execution role plus the step functions policy so that Lambda can call step functions, specifically that particular state machine. Okay, so we can now proceed to the final step, which is to actually see if this all worked and test the application. Let's move on to the next step. Okay, folks, this is step 7. This is where we test the application. This is the moment you've all been waiting for. Did this all work? Let's find out. Let's jump back into the AWS Management Console. And here we are. So we are in our S3 bucket. So that's the Richer Rose Web Game S3 bucket. We're in the properties section. Scroll all the way to the bottom where it says static website hosting. That's your website endpoint. Click on it to open it up. Ooh, there it is. It's the Richer Roast Great Coffee Bean Quest, folks. And I hope you find this really entertaining. So all you need to do as a user is click start, obviously, and then you need to choose your beans, Arabica, Robusta, Liberica. Which one will it be? I'm going to go with Robusta. And now that I've selected Robusta, I have to recommend the roast type. Is it going to be a light roast, medium, or dark? Which do you recommend, folks? I am going to go with medium. Over extracted disaster, try again, lose. Okay, obviously that wasn't right. Let's start again. Let's click Robusta again. Let's go for dark this time. And it says I won. Oh wow, I've now got a punchy Robusta espresso. Boom, fantastic. Okay, well, let's try it again. Let's try Arabica. I'm guessing maybe medium. Coffee gods are displeased. Oh, okay, that isn't very good. Click start again. Let's click Arabica again. How about dark? Over extracted disaster. You know, I actually knew that. Believe it or not, I knew that. I know my coffee. Arabica needs a light roast, folks. And that's where you will get silky Arabica latte. That's perfection. I hope you enjoyed this video. I hope you enjoyed building this solution. Hit the like and subscribe button. Notify it to your friends. Play it on your mobile phone when you're commuting to train and getting bored. Whatever it might be, have a great day. And I'll see you folks in the next video. Thank you.